Welcome to this lecture, and in the last lecture we are discussing about the types of software projects. Before we look at the software engineering principles, we want to form a broad idea about the types of software projects that are being undertaken in the industry, so that we will be able to appreciate the different principles and the principles which are used for which type of software development and so on. We were saying that there are two main types of software projects. One is the product development projects and the other are the services projects. These are the two broad categories of software projects. First, let us look at software services. We said that software services is growing very fast. Right now, the market size for software services and the products are evenly balanced, but then the software services projects are growing much more faster rate. The software services project is basically an umbrella term, in the sense that we have various types of software services projects. For example, we have software customization. Some software needs to be changed little bit to fit the requirements of some customer. Software maintenance. So, this is also a services. Some software is developed, but then an organization has a project to maintain this. A team is dedicated for maintenance for some project, some software, and this is another type of software services is software maintenance. Software testing, maybe some organization developed a software, but then the testing part it has outsourced to a testing to an organization which will do only the testing. So, here the software testing is a software service. In another extreme form, we might have a company which just supplies the contract programmers, and a development company will need some of these for on temporary basis for carrying out some work, and this is also a service. Before we proceed, let us see little bit about why is that the services segment is growing very fast. The number of services projects is large as compared to product development projects. Earlier 50-60 years back, we had very little code written. So, for meeting the requirements of any customer, needed to develop software from scratch. But now, every company and even otherwise there are a large number of projects that have been completed, lot of code is available. So, to develop a new software, lot of reuse made from the existing software. Not only that lot of software is available, but also right now the development work needs to complete very quickly. Just to give an example, let us say an educational institute decides to automate various bookkeeping activities. If it was in the 1950s or 60s, it would award a project to a company, and that will take a year or two to develop the product, to develop the software and install at the educational institute. But right now a month is the average time in which such a work can be completed, and even 15 days. So, the project duration has shortened, and in 15 days somebody cannot really develop a million line code, has to basically tailor some existing software. the speed of conducting business has increased tremendously. Not only educational institute, but all companies, they want software to be quickly developed and installed, and this can only be done by tailoring some existing software, and that is another reason that the services project have really increased. If you look at the market size of the IT industry in India, it has grown rapidly over the last few years. This is a report from the NASSCOM, and if you look at here that the export segment is larger than the domestic segment, and right now almost 10% of the GDP comes from the IT sector, and it was only 1.2% in 98, and before that it was near to 0%. So, the IT industry in India has made rapid progress. Large number of projects are existing, large number of projects have been completed, and this is a growth area, and already 10% of the GDP is from the IT industry. But then before we proceed looking at the software engineering issues, let us just have a small idea about the scenario of the Indian software companies. One thing that is easily noticeable is that the Indian software companies have excelled in the services segment. Almost every project is a services type of project, but then would like to ask you this question, that why is it so? Why there are very few product development projects? Because we said that even now worldwide 50% of the development projects are product development and other 50% is services, but in India almost 100% is services project. What can be the reason? Okay, the reason can be that in product development system there is a large gestation and also risk. You develop a product and then it may do well in the market or it may just flop. Lot of investment just may vanish. But then if a product development project succeeds, then it keeps on giving return year after year, whereas the services project is typically paid only once. But then the Indian companies possibly are risk averse and they concentrate only on the services projects. There are few product development projects and few success stories about products in the Indian context. Now, let us see how the projects have changed over the last 40 years, because if we understand the characteristics of the projects, how they have changed, we will be able to appreciate what are the techniques that were applicable earlier in the early stages, like let us say 1950s and 60s, and at the present time what are the principles and techniques that are applicable and how these have changed. Long back in the initial years of software development, very few software existed. Almost every project started from scratch and projects were multi-year long, 2-year, 3-year and even 5-year projects existed. And the programming languages that were used were like Fortran, Pascal, COBOL, BASIC, etc. And these programming languages have very little facility for reuse of code, and almost no application was GUI based, but now almost every application has a GUI and heavy reuse is made. The project duration has really shortened from multi-year to just couple of months, and the programming languages at the present time support reuse of the code. Now, let us look at the traditional versus modern projects. Services segment is becoming having a large growth rate. Here we tailor some existing software or reuse pre-built library. In the modern projects, the client is a part of the project, the client gives feedback and the project they try to accommodate the client feedback, but earlier, that is the traditional projects, they were product development projects largely, and there once the development starts, no feedback is taken, they freeze the requirements and start according to that. Right now, the customer is part of the project development. Even for very large software, the software is developed incrementally. That means that every 2 weeks or so, the software is installed at the client and then it evolves. New functionalities are added every 2 weeks or so. No software is being developed from scratch and significant reuse is made. Before we look at the software engineering principles, we were concentrating on few basic aspects. Now, let us try to understand about what is computer systems engineering. In many development work, the hardware and software are developed together. It is not that we always develop a software and then make it run on a computer like a desktop or a server. No, there are many systems where the hardware also has to be designed from fresh and the software will run on that hardware. Just to give some examples, let us say a coffee vending machine or a robotic toy. So, here the robotic toy has a special processor, it has mechanical parts and so on, and the software will has to run on that specific processor. These are not general type of processor. So, here we cannot just write a program on the desktop and then we will just get done with it, because the software has ultimately to run on that processor on this robotic system. Or let us say a new health band product. So, there is a processor on the health band which monitors the health and displays various suggestions and feedback. For this type of system, where there is a hardware that needs to be developed and also the software has to work on that hardware, we call it as system engineering. It is actually a superset of the software engineering. But how is the computer systems engineering problem solved? Here first a high level understanding is of the problem is made, then a decision has to be taken which part to be solved by software and which part to be solved by hardware, and then the software and hardware development start parallelly. But the only problem here is that how does the software will be tested, because hardware is also under development. Okay, possibly by using a simulator or something, the software can be tested and developed. So, hardware simulator is used during software development, and then once the hardware and software development is complete, they are integrated and the full system is tested. So, this is a model or a schematic of the computer systems engineering. Initially check whether we can do it, we need to do it, that is a feasibility study. The requirements analysis and specification, understand the requirements and document. then decide which one to be done by hardware, which part to be done by software. Then hardware development, software development proceed in parallel, and after they complete, integrated, and the final system testing is done. And of course, through the entire project duration, the project management activity is carried out to manage the various activities in the system engineering project. Now, let us look at the different software engineering techniques, how they have developed. We are not concentrating on the software engineering techniques themselves, which we will do a little later, but we will see that how they have evolved in time. This will give us an idea to appreciate that how, starting with simple techniques, the software engineering techniques have become more and more sophisticated. In the 1950s was the early computer programming. The programs were small and they were written using language like Fortran. Every programmer was having his own style, that is basically the build and fix programming. Every program was developed according to the intuition of the programmer, what suits a programmer. Languages like Fortran, Algol, COBOL were used later, that was in 1960s, and the assembly language used was restricted, but then the productivity improves significantly with high level language programming. Can you try to answer that why is the productivity much higher using higher level programming languages as compared to assembly language programming? Okay. The answer is that there are two parts. One is that one single line of high level program code, you will have to write many assembly code, and the high level code is easily understood written. Machine language much more involved, because machine language is basically you have to understand the machine architecture, the registers, how data is transferred from one register to another, and so on, load to specific register. But then here we deal with a abstraction, that we deal with only the variables. So, high level language programming is much more simple. It abstracts out the details of hardware organization architecture. But then even though high level programming languages were used, the development was largely exploratory. Build and fix model, and typical program size was only about 1000 line code. But the sizes of the program increased, and the exploratory style became insufficient. It was taking long to develop code, they were having too many bugs, but then there were good programmers who advised that to be able to develop a good program, you have to pay attention to the control flow. So, the good programmers who had experience and who were writing programs well, they advised that please pay attention to the program's control structure. But what exactly is a control structure of a program? The control structure of a program is the sequence in which the program's instructions are executed. The sequence in which the program's instruction are executed may get altered when there are decisions, loops and so on. So, we need to represent a control structure, we need to represent the sequence statements, the decisions, the loop structure and so on. And by looking at the control structure, we can determine in what sequence the program will get executed. So, maybe this statement and after that a decision statement will get executed. Depending on the outcome, either this statement will get executed, if the outcome is false, this statement will get executed and so on. But then the programmers had the advice from good programmers that pay attention to the control structure. You must have a good control structure for writing a good program, and the flow charting technique was developed. The flow charts were used to represent the program's control structure, and based on this the code was written. But then we must know that the control structure helps us to understand the program, a good control structure, because if we want to understand a code having this control structure, we will like to understand the different paths through it, that is starting from the first statement, which are the statements that are executed, where the output is generated and so on. A program that has a bad control flow representation, that is a flow chart representation or control flow representation, that will be very difficult to understand, it will be very difficult to debug and it will have lot of errors in it. But then why is it so? Can you answer that if the control flow representation is bad, let us say something like this, is a very bad control flow representation, why it becomes very difficult to understand a program having such a control structure? Okay, the answer is that if we want to understand this program, then we will have to trace the different paths through it. Let us say we observe the output here and then we look at what is the path that this has taken, what are the statements that have got executed before it and what might have got executed before that and so on, and from where it has got the input. And we need to do that for every path to be able to understand this program. And imagine that there are thousands or millions of paths here. So, to be able to trace the execution through all the paths in this is extremely tedious, it will take long time. But if it had a good control structure and there are only few paths, we can trace the paths, just 3-4 paths, and then we are able to understand compared to a very complex program's control structure. And that gave rise to the control flow based design. The control flow based design said that please have a good control structure for the program. But how does one have a good control structure for the program? They said that see these go to statements, they are the culprits actually, they make the control structure bad. Of course, the modern programming languages, they hardly support go to statements, but the earlier programming languages like Fortran etc., they had these go to statements and these were used heavily. But to look at this in the historical perspective, the assembly programmers they said that see, without jump instruction you cannot write a program basically. So, go to statements are inevitable. Without using go to statement you cannot write sophisticated programs. At that juncture, Dijkstra he published an article in the Communication of ACM 1969, a landmark article called as Go to Statement Considered Harmful, and he wrote about the problems that a go to statement creates, and obviously many programmers who were basically having assembly programming background, they were very unhappy. They wrote counter articles. They said that see, without a go to statement you cannot really write a large program. But then it was proved that to be able to solve any programming problem, that includes the large complex problems, you need only 3 types of constructs: the sequence, selection and the iteration constructs. And slowly everybody accepted that it is possible to write large programs without using go to statements, and this formed the basis of the structured programming methodology. Let us understand what exactly is structured programming. A program is called structured when it uses only 3 types of constructs: the sequence, selection. Sequence is one statement after the other statement, like one arithmetic statement followed by another arithmetic statement. Selection like if, then, else, switch and so on. Iteration like for loop, while loop, do loop and so on. But just see here, there is no place for a go to here. So, a program is structured when it uses only sequence, selection and iteration, does not use go to statements, and also it is a modular program. This is the basic features of a structured program, is that it uses only sequence, selection and iteration type of statements, and also it consists of modules. Of course, sometimes may have to use go to statement. The modern languages do not really use go to statement, but then they have statements like break for premature loop exit, exceptions and so on. So, these are basically not structured constructs, but then occasionally these are allowed due to practical considerations. But let us understand that what is the advantage of structured programming. There are many advantages. One is that, as we were discussing, a structured program has a good control structure because it does not use go to statements. It has few paths, the control structure is simple and therefore, it is easy to read and understand. And since it is easy to read and understand, it is also easy to maintain, because for maintenance we need to first read and understand the program and then decide what to change. It also requires less effort and time for development. Why is it so that we need less effort and time for development? The answer is that if you are developing in a unstructured way, even a small mistake that you have committed will take long time for you to correct, but a structured program can easily correct, understand under the grasp, and therefore, it requires less effort and time for development, and also it is less buggy because you understand it well, and therefore, chances of bugs being there is less, whereas non-structured program you do not really understand how the program works, what are all the paths that exist. There may be thousands of paths and the bug may exist in one of the paths which you never thought existed. So, the structured programming principle has been accepted. It is still a very popular technique. In almost every program that we write, we expect it to be structured program, and of course, as you were saying that the modern programming languages facilitate writing structured programs, because they do not have constructs like goto and so on. So, we will stop at this point of time and continue in the next lecture. Thank you.